Good morning. The video is the Chapter 5 review for Honors Geometry. This is a good review to do, so follow along. The first 6 questions are true-false. So let's take a look at them. If the two lines are cut by a transversal, alternate exterior angles are congruent. Now that is false. Now that is false because it's not always true. They have to be parallel. This is a little tricky. So this is a little tricky. Wait, you got to read it. If two lines are cut by a transversal, alternate exterior angles are congruent. That is false because it doesn't say that the lines are parallel. Okay, it says two lines. In the next one, it says if two parallel lines are cut by a transversal, corresponding angles are congruent. That is true. So this question has parallel lines. The first one did not. The diagonals of a kite bisect each other. That is false. Only one of the diagonals bisects the other. Number 4, the diagonals of a parallelogram bisect each other. That is absolutely true. The diagonals of a rectangle are congruent. That is absolutely true. And to prove a parallelogram, you must prove that one pair of sides are congruent. That is false because it could be a trapezoid and not a parallelogram. Okay? Number 7, find the perimeter of the isosceles trapezoid. The only thing that we know in this picture is that it's isosceles. So these two legs are equal, and these two angles are supplementary. Or no, these two angles are congruent, these base angles. So these are the upper base angles, and they are congruent. So, in order to find the perimeter, I have to find the EFF, the equation from the facts. And so that is 9x plus 92 equals 32x. And so I end up with 21x, or 23x rather, equals 92. So here x equals 4. 23 times 4 is 92. So x equals 4 in this problem. And now I substitute it in. For this base I get 9. For this leg I get 4. For this base I get 12. And since these two legs are congruent, I get 4. So now I add them up, okay, and I get 39, or 29. 9 plus 4 is 17, plus 12 is 29. Okay, again, it's the equation from the facts that is very helpful in this problem. Number 8 and 9 are crook problems. So this problem here is required an auxiliary line. These two angles are supplementary, so this angle is 30. I don't know this angle, but this angle and this angle are alternate interiors, so this is 40. So this crook problem is 70 degrees. Number 9, okay, this angle is 60. I'm going to draw this and this. Now this angle and this angle are alternate interiors, so I'm going to put a 60 here. Okay, this angle and this angle are alternate interiors, so I'll put a 60 here. Now I don't know what this one is, but I know this is 95, okay, and this angle here is 85. But this angle here is 95 because of the corresponding angles. So this, if this angle is 95, this angle right here is the supplement of that, which is 75. Okay? No, 85. So angle X is 60 plus 85, which is 145. Okay, so this one's a little tricky. Now you have to put 85 here. You could say these two are supplements. And then these two are alternate interiors to get it also, to get this 85. Okay? All right, number 10. We know that angle 1 is 9x plus 60. And we know that angle 2 is 8x minus 2. And we know that angle 3 is 6x plus 22. Now, what we have here are two parallel lines. Okay, now we have these two, this transversal right here, And we have this angle and this angle as alternate interiors, so they're equal. So what I'm going to do is I'm going to add this expression and this expression and set it equal to this expression. So I will write 8x minus 2 plus 6x plus 22 equals 9x plus 60. Now on this side of the equation is 14x minus or plus 20 and 9x plus 60. So I'm going to get 5x equals 40, so x equals 8. Okay? So 9x minus 14x minus 9x is 5x, and 20 minus 60 is 40. So 5x equals 40 is what I get, and I get x equals 8. Now, I need to find the measure of angle 3, so I'm going to substitute it in. 6 times 8 is 48, and plus 22, this is 70. That's what I get for the measure of angle 3. So the equation from the facts is adding these two expressions to set it equal to this expression, because these two angles add up to the same as this one. They are alternate interior angles. Number 11, okay? It says a pair of consecutive angles in a rhombus have the measures of 7 to 5. Find the measure of the smallest. A rhombus is a parallelogram, so the consecutive angles are supplementary. So this angle and this angle add to 180. So I get 7x plus 5x equals 180 as the equation from the facts. So 12x equals 180. Okay, so x equals 15. Okay, so I get x equals 15 for that, and I am going to find the smallest angle. So the smallest angle is 5 times 15. So 5 times 15 is the smaller one, and that's 75. 7 times 15 will be the supplement of this, which is 105, but we don't want that. We want the smallest angle. So that's 75 degrees. Number 12, ABCD is a kite, BY is 4x, DY is x plus 75, 7.5. Okay, so we know right away that in a kite, these two segments are congruent. The blue segment and the orange segment are congruent. So AB is 10x plus 3, and BC is 5x minus 4. And we also know in a kite that these two sides are congruent, and these two sides are congruent. Okay, so we want to find the perimeter of this kite. So the equation from the facts here is that 4x equals x plus 7.5. 4x equals x plus 7.5. Now, that gives me an x, 3x equals 7.5, so 3x equals 7.5. So x equals 1.5, no, 2.5. 2.5, all right? So I'm going to substitute it in here, all right? 5 times 2.5 is 12.5, so 12.5 minus 4 is 8.5. So this side is 8.5 also. So now 10 times 2.5 is 25. So 25 plus 3 is 28. So this side is also 28. So we get 28, 28, 8.5, and 8.5. Now, 8.5 plus 8.5 is 17. And 28 plus 28 is 56. So 56 plus 17 is the perimeter, and that's 72. 73. Okay, so that is how you do that problem. Please stop the video and find out how to do these, okay? Find out and slow down, take your time. It's okay. You can take your time. You can do this. Number 13 and 14, these are proofs. And number 13 is a pretty easy proof, to be honest. Well, maybe not. So anyway, yeah, so the way we're going to do this is a parallelogram. Okay, and then angle 1 is congruent to angle 2. Now, we want to get BE, which is this segment, congruent to this segment. So I'm hoping you can see that it's this triangle we want to get congruent to this triangle. Okay? And we're going to do it with angle side angle because these two angles are congruent because they're given to us. These two angles are congruent because the opposite angles in a parallelogram are congruent. And these two sides are congruent because the opposite sides in a parallelogram are congruent. Okay? So we're going to get these two triangles congruent by angle side angle. And then we're going to get BE congruent to DF by CPCTC. I'm stopping the video now, writing the proof, and then I'll start the video again. So I did the proof now. So you have the two givens. You have CD congruent to AB because if it's a parallelogram, opposite sides congruent. And then you have the angles if it's a parallelogram. And the two triangles are congruent by angle side angle. And the two sides were congruent by CPCTC. Moving on to 14, okay, it says that, I'll talk about it and then I'll write the proof again because I'm almost out of time. So angle 1 is congruent to angle 2, and AE is congruent to CF, and DE is parallel to FB. Okay, so if we wanted to extend those, we could a little bit. Okay? Now, the way we're going to get this, we want to prove that ABCD is a parallelogram. Okay? Now, we're going to say that these two sides are going to be parallel here, this side and this side. Okay? And then we're going to prove that because they're parallel because of angle 1 and angle 2. Okay? Now, we also know that this segment here, okay, this segment here is going to be congruent to this segment here by addition. All right? Now, if you don't see it already, these are the two triangles that we're going to get congruent. It's going to be this one and this one. Okay? So we're going to get those two congruent, and then the way we're going to do that is we're going to use these two parallel lines, okay, by saying that these two angles here are congruent. All right? So they're alternate interior angles. Okay? So we're going to get the two triangles congruent, and then we're going to get these two sides parallel because of angle 1 and angle 2, and then we're going to get them congruent by CPCTC. These two sides we're going to get congruent by CPCTC because we're going to get the triangles congruent. Okay? Now, I'm going to make this last proof a separate video, so I don't want to hurry it. Okay? So because I have about a minute left because my max recording time is 15 minutes. Okay, so remember, be careful with the true and false. Okay, always look for the equation from the facts. Okay, crook problems, equation from the facts again for number 10. Okay, again, equation from the facts, equation from the facts. You can use your sheet on your test. All right, and then we did a proof that was fairly simple, but you've got to be able to see it, okay? And then the last proof I will do on a separate recording.